Hi, grade 9. So I'm going to try to show you how to work on part 1 of our 3-part assignment that I sent out today. It's also your last assignment, which is pretty awesome. I'm going to post one more video probably on Thursday or Friday just to kind of wrap up the year. But I just wanted to quickly talk about how to use the info from the table that I can't print out because I'm at school. Haha. How to use info from the table, put it onto this graph, and then also how to draw that line of best fit. So I'm going to get my 2-meter stick because I don't have a ruler, haha, and I'm going to sketch out the rough beginnings of my graph here. I'll make it nice and big because I have what is this? I have the liberty of doing so. So again, this is a 2-meter stick. It's a bit tricky to do good work with, but you guys can use all sorts of different things. Okay, 2-meter stick. Now, the one in the question will show something called a break. So if you're not starting right at 0, sometimes you'll start at 0 here. If you're not starting at 0, you can draw a data break. So that just says we're not starting at 0, and then we can decide where we're going to start. In fact, I'm going to extend this for 2 pieces. And then my first point is going to be 12.9. 12.9, and it seems to be going up by 0.1 at a time. So let's see, 13.0, 13.1. I'm going to try to make this smaller so it fits. 13.2, 13.3, 13.4, and so on. I have graph paper. You can use line paper for this, but I recommend graph paper if you have it. 13.7, 13.8, and just for good measure, I'll go up to 13.9. Okay, so we've got our first little axis here. Also, it has a title. The title is winning time. This is our y-axis, just as a heads up. And down here we've got our x-axis. Sorry, and it's called year, and let's get those years down. So again, I can't show you the data, but it says year, winner, and winning time. So we can ignore that winner column. We can just go straight to the year column. It starts in 1956 and goes up to 92. So we can start here in 1956. Maybe I'll put a line there. Skip. I don't know if I'll do it that way. Hang on. Sorry, grade 9s. I'm going to patch up my line here. Okay, so I'm going to do every 2. Skip 2, 1960. It seems to be going up by 5, so 1964. Skip 2, 1969. Nope, 1968. What the heck? That's unusual. 1956, 1960. Yeah, isn't that weird? It's going up by 4s. No wonder. I'm confused. Sorry about that, grade 9s. 1972, 1976, 1980, 1984, 1988, 1992. What a good year. Okay. So now I can put down my gigantic ruler for now, aka my 2-meter stick. Now it just comes down to graphing. So this is something we've looked at a little bit. Note at some point we're going to have to put some kind of title, but I'll leave that blank for now. I'll leave that up to you. We can just label some of the points. So we'll do the first few with you. In 1956, the winning time was 13.5 seconds. So 13.5 happens to be right there. Okay, I'll do the next one as well. 1960 was 13.8. So he actually got slower. It took him more time to get to the finish line. 1964, it was 13.6. So I'm just following again. So 1968, 13.3. So we're starting to finish in less and less time, which is good. 1972, 13.24. 13.24, so about halfway. 1976, 13.3. So it's about here. 1980, 13.39, almost 13.4. Very close. 13.2 for 1984. Good book if you haven't read 1984. 1988, 12.98. Wow, suddenly we're getting pretty fast. And then finally, 92, 13.12. So 92, 13.1, and a little bit. Okay, so here we have our data. As you can tell, it starts off being quite high. It takes a long time to finish these races, and it slowly seems to go down this way. So when we're trying to line of best fit, the trick, there's a couple different methods. One of them is pretty mathematical. You have to use a certain formula. That's called like a linear equation formula. We're going to avoid that. Instead, we're going to use something straightforward. It's called the eyeball method. So all we do for the eyeball method, we can't just totally wing it. I can't just start drawing a line. But we have to just be a little bit strategic. How many points do we have? So let's add them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points. 10 points. And essentially, we want to draw a line where five points are above and 5 are below. So essentially, we can take our ruler, or in my case, my 2-meter long stick, and I can try to find a way. Maybe the first 2 points start out kind of in the middle, and the last 2 points start out kind of in the middle, and find a way if I can rearrange the way that it's organized so that I have exactly 5 above. Maybe I'll try to flip it this way so you can see better. About 5 above and about 5 below. So there's 1, 2, 3, 4, 5-ish. One of them's right on the line. So maybe that's even a good example. 1, 2, 3, 4, 5-ish. So I will do an approximated eyeballed line. Now, is that perfect? No, but that does give us an indication of our graph. And this is kind of our last little unit. We've got 3 big questions on lines of best fit. This is how you kind of eyeball a line. And as you can see, there's 1, 2, 3, 4, 5 below, and 1, 2, 3, 4-ish, 5 above. This is about as accurate as you can get without doing a whole ton of weird math, and you can kind of calculate the distance between this point and that point, and it becomes really arduous and quite annoying. It's important for statistics, it's important for real life applications, but in general, if you're looking at a table that's presented to you by the news or something, it's good to be able to just have a general idea of that trend. So our trend is a downward trend. You might even call it a negative correlation. That's another name for it. If it went up, it would be an upward trend, and it would be a positive correlation. So I'm going to leave it at that. I think this is enough information for you to go ahead and input this data. It says in your instructions to extrapolate. So I'll also mention that a little bit. Extrapolating is if you take the data that you have, you can make estimates based on your line. So if you go outside of the data that you have, like let's say you wanted to find a date earlier than 1956 or later than 1992, we can approximate using this line. It's not going to be perfect, but it's a really good educated guess. So in your question, it says extrapolate to 1952. So that means take this line and extend it a little bit further, maybe with a ruler, but my ruler is so impossibly large. Here we go. Hang on. Let me just line that puppy up again. I'm going to go beyond the data and below the data. So if I wanted to extrapolate back to 1952, I could count backwards now. So this would be 1954, and this would be 1952. Now I can move up this line and make an approximate guess. It would probably be around here, probably around this 13.8 mark. But do I know that for sure? No. If I wanted to guess the winning time in 2000s, I can continue my line this way and see how far down it goes. So maybe when you're doing this on your own, start this a little bit smaller and go from there. Other than that, grade nines, I'm going to let you go for now. I'm going to post this, and I'll have something else posted in a little bit. Make sure you come to our 2:30 Google Meet, and take care. If I flip this up, I'm going to be upside down. Ready? Ah!